It's Marianne. I want to show you some resources you can use in your classrooms that really are engaging and help you connect or integrate science and math. Some of them, a couple of the resources, you'll also be able to integrate the engineering piece. But for now, I'm going to start with PhET, PhET. And these are online simulations. If you just type in they're from the University of Colorado in Boulder, and you can, browse through them. But I've put on this masses and springs PhET just to show you, or simulation just to show you what they look like. So this is masses and springs basics. So they look pretty simple, but they're actually quite complex. So this simulation has two springs. They're both right now at the same strength. So in science, the inquiry process has kids like ask questions and then do some research and then state a hypothesis and then design an experiment to test that hypothesis. And um, um, there's always like an independent variable and a dependent variable. And the independent variable, I tell my students, is the one that you're changing on purpose. So like I for independent, I am doing this. And I know, and the dependent variable is the variable that changes in response to changing changes in the independent variable. In math, it's usually the independent variable is graphed on the x-axis and the dependent variable is graphed on the y-axis. So there's lots of connections we can make here. So in these simulations, you can do a lot of data collection where you're looking at the relationship between something and something else. So in this case, we have spring strength here, and I can see these different weights down here. There's also some unknown weights. And then I can look over here and I see, okay, unstretched length, resting position, movable line. Okay, so I guess I can click on these things and they're going to give me some more. So I can move this line. And look, I have a ruler over here. I'm hiding something behind here. I can change the speed, normal or slow. And I have a ruler here, which is a centimeter ruler. So I guess I can make some measurements. So if I take, let's say, the 50-gram weight, and now I have the unstretched length is here, and I have the resting position, and then I have a line where I can, I guess, use this to do some measurements too. But if I want to measure the distance between, let's say, the unstretched length and then the resting position, now, I don't know, does that look like 0.9, 0.9, or wait, 9, 10, 20, 30. I can't even use my own metric ruler here. So that looks like, it's hard because, so I'm saying 9 centimeters right there. So I would say, if I was a kid, I would say, well, if I added twice the amount of mass, okay, would I get twice the distance? Because the spring strength is the same for both. I'm not adjusting that. Right now, I'm just looking at the effect of mass on how far the string stretches. So let's go over there and see. Not quite, unless of course I'm not quite having the ruler at exactly the same place. It's not bad, it's close. Looks like 16, 17 centimeters. It's close, it's not perfectly double. But that's what these simulations can do. You can ask every kid, talk about differentiation. Every kid could ask their own question. Like one kid might say, well, how does the strength of this, so now I'm making this spring stronger, so it's stretching less because I can do that. I can do that right here. And what if I did that? Then that really looks to see. I'm trying to get that double. Oh, I almost did it there. Still a little less. That's interesting. So lots of different questions you could ask and then get the answers by collecting some data through a simulation. So the problem with these is that there are no supporting materials. So, if you want to use one, you have to tell kids exactly what you want them to do. Like, and I've done that before, created the documents that say, click on this, click on that. Clearly, if you use video, like I'm using right now, like Screencastify to record videos, it's a lot easier to make a video and show them exactly where to click than it is to write it all down. But you could do either one, and make your own worksheets, and create data tables for them to collect data and record data. So I like these simulations. So you're going to spend some time exploring this. The next simulation, these are really good. These are called Gizmos, but you have to pay for these. You can actually browse through. There's some free Gizmos. I'll show you how I usually find them. I go by, standard. So if we're here, grades 6 through 8, and I'm in, I'll go, usually the physical science ones are really good. I'll show you one that I've used before. Oh, it's not in here. Yeah, okay, so it's kinetic and potential energy. I've done roller coaster physics and sled wars. They're both very similar. Now notice you only get a 5-minute preview of these. So once you're done, but again, same kind of thing. I can, my independent variable could be the mass of the car. And the dependent variable here is, do I have enough energy to break that egg? Okay, so it did not break it. So if I reset and go to 50 grams, change the mass of the car, will I have enough energy to break the egg? And I did. So what's really cool about this one is you can vary the height of the hill. And I'm going to go back to that 35-gram car, but this time hill 1 is at 100 centimeters. And I'm going to see if I can break that egg, and I can now with, even with the same mass, I increase the height of that first drop. And so, and there's really good, like you can show the graphs here, what's happening to all, like this is kinetic energy versus time, total energy versus time, potential energy versus time, etc. This advantage here is that it comes with all supporting information. Like, so they have these Google documents that tell you exactly what to do. And I'm trying to make a copy. So here goes. And I can do this without being logged in. So you can do the same thing. So unfortunately, though, the kids, like I said, only have that 5-minute limit unless you buy them. And it's pretty expensive. But what's really cool, though, you can get some ideas of how to create really good documents that go along with simulations if you're using PhET. But these are also differentiated. So for example, activity A is a little easier than activity B, and that's easier than activity C. So you can give certain activities to certain kids, which is really an advantage. So PhET, same, very similar. They have, it's an online simulation and you get data, but no supporting materials. You have to make them yourself. But Gizmos have all the supporting materials that go with these, and they're really good. And you can make it bigger, to expand the screen so you can really see what's going on. And the last website or resource I'm going to show you is, in 5 minutes is really not a lot of time once the kid gets in. So it would be very frustrating, I think, to try to use these if you haven't paid for a subscription. This requires you really to talk to, like if your science and math teachers get together. So in my district, we all use this, and it's about $3,000 for the entire junior, senior high school, 7 through 12. And they, and that's not bad. You're charged per student, so there's 700 and some kids in the school. But $3,000 for this type of resource for every single math and science student is incredible. I highly recommend them. But the last resource I'd like you to investigate right now is called Science Buddies, and this is a great resource. So if you're looking to try to find some, a way to collect data in your classroom, and especially if you're a math teacher and you're not really sure, um, uh, like, how do I do that? You can go here and then browse by, by area of science. And so if I was a math teacher and I don't have a lot of materials, I'm going to go with like maybe something simpler that I can do, maybe like kitchen chemistry kind of things, or cooking and food science. You just want to get numbers out to kids and have them then use those numbers and, do other things with those numbers. And um, and so I would browse through here. There's always like, well, maybe not that one. Lowering the freezing point of water. Kids love to make ice cream. So this is a great one. This is a calorimetry experiment, like burning calories. How much energy is stored in food? In math class, if you had them burning stuff, but safely. So what I love about these and this resource is that there's always a summary, there's background information where it gives you the introduction to all the science concepts you need and the vocabulary words. So this is like a chemistry experiment, but it's also connected to biology and physics. And you can see the nice formula here, the relationship, calculate the energy stored in the water. So we're looking at the change in temperature. And so you can, specific heat here, and some high level math here. And by the way, I randomly picked this one. So I know there's a lot of math teachers in our class, but, and then here's the materials you will need to do this, but really it becomes pretty simple. You just get cans. So to make a calorimeter, you just have to like the waters and the temperature change. So you you get a cork, you stick some food to it, you set the food on fire, and when this burns, the heat energy given off by this burning food will be transferred through radiation to the can, and then by conduction to the water that's in this can. And so you'll measure the change in temperature of the water to measure how much heat energy was produced by your burning food. But the point here is that they're simple materials. It looks a little more complicated in the diagram, but then they show you like nice pictures of really, it's just a can, like a green bean can within a larger can. That's all you really need. And they give you the data tables, and they tell you like exactly and show you pictures of how to do this and sample, what do you call it, calculations. Okay. And then they even go on, how do you make it your own? Like, what are some other questions you can do? And what other things that you can do to, make it your own, and then help, etc. So I really like the way Science Buddy sets this up. I'm going to go back. Well, actually, I'll go this way by area of science, because I did that one had a lot of math in it, but not all of them do. I love the chemistry and cooking chemistry ones, but so hit on electricity, see what comes up. Build a simple electric motor. I'm trying to think of even like building a circuit to detect ripe produce. Uh, what I really am looking for is just a way for math teachers to collect a lot of data in their classroom without spending a lot of money, but or or just how to get kids engaged in the inquiry process, um, in your classroom, in your math classroom. All right, that's it. Those were the 3 resources I wanted to show you this week. Thank you.